Good day everyone! In this video, we will create a simple circuit using the inverter gate. Inverter gates or NOT gates are commonly used to invert signal inputs, generating complementary data. They are often paired with other logic gates to perform various functions, especially in the field of electronics engineering. Our objectives in this activity are to familiarize ourselves with the breadboard and other basic electronic components, then to demonstrate and simulate the basic function of the inverter or NOT gate and its applications. Before we begin, let's review some basic safety precautions when handling electronics. First is to use personal protective equipment when necessary. Example, rubber gloves and safety goggles. Second, avoid wearing static-prone clothing and ground yourself properly to prevent harm or damage to components. Third, handle all components correctly and with care, especially with the sharp pins of the electronic parts. Lastly, unplug the power supply when not in use. As for me, I am not wearing a PPE right now because we are only handling a 5-volt battery supply, which is not actually dangerous or harmful to us. Now, let's prepare the following electronic components and materials before we start. We need one 5-volt battery. We are using a Raspberry Pi hooked up to a power bank. We also need one large breadboard, some male-to-male connecting wires, 5 5mm LEDs, 5 100 ohm 1/4 watt resistors, one 74LS04 IC, one 4-pin button, and an optional multimeter. Since I don't have a multimeter on hand, I'll just simulate my circuit. Let's begin! Step 1. While optional, I encourage you to prepare a circuit diagram to quickly and efficiently have the installation of components on the breadboard. Number 2. Prepare your breadboard and decide where to connect the positive and ground lines. Third step. Place the 74LS04 IC and the 4-pin button carefully according to the circuit diagram. Handle the components with the sharp sides away from you to avoid injury. Step 4. Pair each of your 5 LEDs with a 100 ohm 1/4 watt resistor and place them on the breadboard according to your circuit diagram. Step 5. Once all the essential electronic components are in place, use the male-to-male connecting wires to connect them, following the circuit diagram. One helpful tip is to color code the wires uniquely for each LED to easily troubleshoot any issues with misplaced components. Step number 6. Connect the positive and negative sides of the battery to the appropriate lines on the breadboard. Lastly, review all the circuit components if you encounter any errors in the assembly. Now that the circuit is assembled, what do we observe? As shown in the circuit diagram and the breadboard shown, when D0 is 0, that is, the button is unpressed, only the second and fifth LEDs light up. However, when D0 is 1, that is, the button is pressed, only the first, third, and fourth LEDs light up. These occur because the input signal D0 is inverted by the NOT gates, determining whether each LED will light up or not based on its preceding signal. In real-world applications, inverter circuits are excellent for data handling, generating complements of binary inputs, and much more. Additionally, NOT gates, when combined with other logic gates, can handle more complex tasks in fields such as signal processing and microprocessors. This marks the end of the video. I hope you learned something about the NOT logic gate, its function, and its applications. See you in the next video.